Hi, so in this video, we'll be discussing a question which is taken from this particular question paper code. So you may please pause the video and read the question. If you have read through the question, let's start the discussion. 2.56 gram of a metal oxide, MO2, is reduced to 1.92 grams of metal M. What is the relative atomic mass of M? This question is really tricky. uh, it, there are so many points where you could be misguided and totally get out of track. So be careful. So now the question clearly indicates that MO2 is reduced to metal M, meaning there is a chemical reaction that is going on. So if there is a chemical reaction, I should have a chemical equation as well. So let me try to put the equation here. MO2 is forming metal M. That's all I have. I'm not given the reducing agent, where another metal is used as a reducing agent, where the carbon is being used as a reducing agent, where the carbon monoxide is being used as a reducing agent, or whether it is simply heating. We are not provided any information regarding the reducing agent or other reagent which is involved. Other reagent we have to include as a reactant in this balanced equation is not provided. Neither we are provided with the byproduct. We are not provided we are not provided with any information regarding oxygen, whether it is molecular oxygen, whether oxygen is existing as a compound. We have no clue in the question. So it is impossible to write a balanced chemical equation here. But that doesn't mean we cannot solve the problem. So it's given that mass of metal oxide is equal to 2.56 gram. So I'm given the mass of metal oxide as 2.56. Also, I'm provided with the mass of metal M as equal to 1.92 grams. So now, using this information, I can find out the mass of oxygen. How much is the mass of oxygen? Mass of metal oxide is equal to mass of the metal plus mass of oxygen. So this is 2.56 is equal to 1.92 plus x. I don't know how much it is. So when I'm solving, I'll get it as 2.56 minus 1.92. That's equal to 0.64 grams of oxygen. So in the given compound MO2 weighing 2.56 grams, there is 1.92 grams of metal in it and 0.64 grams of oxygen. Metal oxide, this is 2.56 grams. Metal is 1.92 grams. And oxygen is 0.64 grams. Now, from the mass of oxygen, I can calculate the moles of oxygen present in it. Or, in other words, the 0.65 grams of oxygen, I can convert it into moles. What is the formula? Number of moles is equal to mass over atomic mass. So 0.64 by 16. Don't write 32 because 0.64 grams doesn't correspond to oxygen molecule. It is the entire mass of oxygen in the compound MO2. So you can imagine that it's something like this. There's a metal at the center, oxygen on either sides. It's not O2 molecule. It's metal bonded to oxygen. So you cannot use 32 here. You have to go with number 16, which is the atomic mass. So this will be equal to 0.04 moles. Now let's connect it with the metal oxide. So one molecule of metal oxide is having two atoms of oxygen. Atoms of oxygen. Or I can write the ratio between MO2 is to oxygen in it. When I'm saying MO2, the whole MO2 compound, the whole MO2 molecule is to oxygen is in the ratio 1:2. One molecule, this entity has two oxygens in it. Just like we say, one person has two hands. One molecule has two oxygen in it. So if that's the case, if I'm having, in that case, if I'm having 0.04 moles of oxygen, how much of MO2 will be there? Or how much of MO2 will be containing 0.04 moles of oxygen? Let's do a cross multiplication and find it out. Just cross multiply. Here you will be getting 1 times 0.04 is equal to 2 times question mark. I don't know how much it is. So this question mark will be equal to 0.04 by 2, which will be equal to, which gives me 0.02 moles. So what am I getting? MO2, it has a mass of 2.56 grams and its moles is 0.02 moles. Metal M has a mass of 1.96 grams, but we don't know the moles of it. And oxygen present in the compound is weighing 0.64 grams, or it corresponds to 0.04 moles. Fine. So here I'm having the mass, I'm having the moles. So again, using the formula, number of moles is equal to mass over molar mass. I'll be able to convert, or I'll be able to find out how much is the molar mass of my compound MO2. So let me do the substitution. So 0.02 is equal to 2.56 over molar mass. Or in other words, I get the molar mass is equal to 2.56 by 0.02, giving me 128 grams. Keep in mind, there is an option 128. Option C is 128. If you choose that option, it's going to be wrong because this 128 is not the molar mass of the metal, it is the molar mass of the compound MO2. Meaning we have to proceed way ahead. We have to go ahead one more step. We have to calculate the molar mass of the metal. So MO2, this has a molar mass of 128. Now in this compound, I am having metal M having a molar mass, having an atomic mass of AR. I don't know how much it is. I don't know how much it is. And there is oxygen also. And there are two oxygen atoms. So two oxygen atoms will contribute 16 plus 16. In other words, I can write this 128 is equal to the atomic mass of metal M metal M plus 32. So atomic mass of metal M, or I can say it because this is for 1 mole of the substance. I can either also refer to it as the molar mass. That is equal to 128 minus 32. This is going to give me 96 grams. So this is the answer. Option B is the answer. I hope this explanation is clear to you. Thank you.